Good morning, students. In today's class, we are going to discuss about fuzzy C-mean algorithm. So before discussing about the fuzzy C-means algorithm, just I will give you an overview of what exactly the clustering is, and then we'll discuss about fuzzy C-mean algorithm. So as you know already, clustering is nothing but it's a distance-based unsupervised machine learning algorithm where data points that are close to each other will form a group. So you can see here these data points are close to each other, so they are in one group. These data points are close to each other, so they formed another group. In the same way, we have another group which we'll call it as K3. So these are nothing but group of similar kind of objects or similar kind of data points. So this is nothing but we'll call it as cluster. Fine. Now, whenever I'm talking about clustering, clustering could be of two types. One is called hard clustering and another one is called soft clustering. So if you remember in the previous class, we have discussed k-mean algorithm, and there we discussed that each data point will belongs to a single cluster. So when we are saying that every data point will belongs to a single cluster only, then it is called as hard clustering. So I hope it is clear what exactly the hard clustering is. Okay. So when we are talking about hard clustering, the data point which belongs to a single cluster, then we'll call it as hard clustering. So as you can see in this diagram, so every data point, these data point belongs to this cluster and this data point belongs to another cluster. So data points belongs to a single cluster only. So this is called hard clustering, and the example of hard clustering is k-mean clustering and k-middoid clustering. Okay. Now we are talking about the soft clustering. So when I'm saying the soft clustering, the fuzzy C-mean clustering algorithm is called soft clustering. Soft clustering is nothing but when there is a probability that a single data point can belong to two different clusters, then it is called soft clustering. So understand what exactly the soft clustering is. When I'm saying a single data point, there is a probability that a single data point could belongs to a two cluster or more than two cluster, then we'll call it as soft clustering, and the example of soft clustering is fuzzy C-mean clustering algorithm. So fuzzy C-mean clustering is a method of clustering which allows one piece of data to belong to two or more cluster, and this method is frequently used in pattern recognition. So whenever you want to find the pattern in the given image or in a given data, then we can use fuzzy C-mean algorithm. Okay, so this is all about your fuzzy C-mean algorithm. Now, how I can implement fuzzy C-mean clustering? Okay, so for the implementation of fuzzy C-mean algorithm, we are taking a simple example and we'll go step by step. So we'll understand that how fuzzy C-mean algorithm works. So what is my first step? So what we are saying in fuzzy C-mean that a data point can belongs to a two cluster or more than two cluster also. So in this example, we are considering that we have two cluster and we are finding the probability that particular data point belongs to which cluster. Okay, so we have some data points which is 1, 3, 2, 5, 6, 8 and 7, 9. Okay, now first step what we are going to do, we have a data point and using those data points we are finding the number of cluster. Okay, I'm saying here that we can have two cluster and we are writing here randomly that we are initializing the membership table. So this table is nothing but we'll call it as membership table. In this table, we are writing randomly the probability that this data point belongs to cluster 1 with the probability of 0.8. The same way this data point belongs to first cluster with the probability of 0.7 and with the probability of 0.3 for cluster 2. The same way 4, 8 belongs to cluster 1 with the probability of 0.2, and with the cluster 2 it belongs to probability of 0.8. So in this way we have prepared this membership table. In the beginning we are writing these values randomly, and in further step we have to find the actual probability of these data points to belongs to the particular cluster. So this is about your fuzzy C-mean algorithm. And remember this, the sum of these two values should be always equivalent to 1. So you can see here everywhere the sum of the probability of to belongs to cluster 1 and cluster 2 is equivalent to 1. Okay, here everywhere. So it should be always equivalent to 1 whenever you are filling this random values in the membership table. So clear, the first step what we are going to do, we are preparing a membership table with random values of probability for each data point. So these are my data points I have written, and this is the cluster. How many cluster I want to form here? So I want to form two cluster here, and I'm checking that what is the probability of 1 comma 3 belongs to cluster 1, and the same way what is the probability of 1 comma 3 belongs to cluster 2. So we have written random values. In the next step, our agenda is to update these values mathematically. Okay. Now, what I have to do? So, whenever I'm saying I'm making a cluster, I have to find the centroid of the cluster. So, first step is we are preparing the membership table. Second step, we are finding the centroid of each cluster. So, for finding the centroid of each cluster, we are using the formula, centroid formula, which is representing here as V of ij equal to summation of k equal to 1 to n mu of ik power m multiplied by xk divided by summation of k equal to 1 to n mu ik to m. So this is my formula. Okay. So here mu is nothing but your fuzzy membership values. M is nothing but fuzziness parameter generally takes as 2. So in the most of the cases whenever I am saying M, it's a fuzziness parameter and we are taking fuzziness parameter value as 2, and xk is nothing but your data point. So these are the data points which we are talking here. So xk is my data points. Now I'll have to find the centroid here for every cluster. So if I want to find the centroid of every cluster, what I have to do? The first time what I'm doing, I'm finding the first component of first centroid. Okay, so I have to find the first component. So that's why I've written here 1 for which for first centroid. So first component of first centroid, so it will become V11. So I'm talking about this particular cluster. So when I'm keeping these values here, V11. So what is my k here? K value will be from 1 to 4. Why 1 to 4? K is representing here data points. So how many data points we are having? We are having here 4 data points. So my k value is 4 in this case. So your k is nothing but 4. So k will start from 1 to 4. Okay, so 4 times I have to repeat this thing. Fine, xk is nothing but the first component of the first data point. Xk is my first component of the first data point. So you fill the value in this formula and you will get the result. So first time, what is my mu ik power ik of m is nothing but you can see here we are talking about the first component of first centroid. We are talking about first component of first centroid. Then what is happening? So what is my value here? What is my value here? It is 0.8. So we are writing here 0.8. Fine. Next, multiply by which data point I'm talking? I'm talking about xk. So what my xk? Xk I'm talking about the data point 1. First time I'm finding for 1. Next time I'll find for 3. So I'm talking about first data point. So my xk value will be 1 multiplied by 1 because I'm finding the first component of first centroid. So 0.8, the probability of 1 belongs to cluster 1 is 0.8. So we have written here 0.8 multiply by xk. Xk is nothing but the component which I am talking, which is 0.1 plus the same way. Now I have to find for this particular data point, which is 2. I have to find for data point 2. So this is for data point 2. What is probability here? The probability is 0.7. So we kept here value 0.7. So in this case, we kept the value here 0.7. Fine. So we kept here 0.7. M value is 2. So we kept here 2. Multiply by what? Multiply by the data point. So what is my data point value in this case? My data point value is 2. So we multiply with 2 here. Okay. Plus now the next time, what is my data point? Next time I'm talking about this data point which belongs to cluster 1. So data point is what? 4. And the probability of that particular data points belongs to cluster 1 is 0.2. So we kept here 0.2 multiply with the data points plus next time, what is my next data point? Next data point is 7. The probability of 7 belongs to cluster 1 is 0.1. So we multiply 7 with 0.1 square because m value is 2 here. Divided by k equal to 1 to n mu of ik to the power ik to m. So what is my value here? How many values I have to write? 4 times. K is equal to 1 to 4. So what is the probability for first component belongs to cluster 1? The probability is written here. So just I have to write 0.8. M value is 2. So 0.8 whole square. The same way 0.7 whole square plus 0.2 whole square and 0.1 square. So this value we have written, and when we calculated this, we got the result 1.568. So clear that what we have identified, we found the value of V11. V11 is nothing but first component of first centroid. In the same way, I have to find out the second component of first centroid. So what I have to do? Now I have to find out V12. So V12 is nothing but, now I am talking about the second component of first centroid. So what I have to do? These one, see, you see here, these 1, 2, 4 and 7 will be replaced with what? The second value of the your data points, which is 3, 5, 8 and 9. So we'll replace all these values 3, 5. So it became 3, 5, 8 and 9, and other things will remain same, because the first time we find the centroid for the first component, and the next time we are finding the centroid for the second component. So we got the result, which is V12 is 4.051. So we found V11 and V21. V12. Now you just think what we have done. We have done this thing for cluster 1. Now I have to repeat the same thing for cluster 2. So now I have to see the probability for cluster 2 also. So I have to repeat the same thing, means I have to find for second component, first component of second centroid and second component of second centroid. I have to do this thing, so I have to find what? V21 as well as V22 in this case. So where I consider these values. Okay, we are going to consider these values now, because I am talking about the second cluster, and I have to find for this as well as for this. So we have to find out V21 as well as V22. So when we repeat the same steps, you can see here, we have to find V21 and V22. So we found the values. If we put all these values here, you will get the result, which is 5.35 and 8.215. So we found four values, V11, V12, V21 and V22, which are nothing but the centroids. We found the centroid of my data points. Now our centroid values are nothing but, we got the centroid values, which is 1.56, 4.015, and the second time for cluster 2, which is 5.35 and 8.215. So we found in the second step, we find the centroids. After finding the centroids, the next step is nothing but, we have to find out the distance of each data point from the centroid. Now I have to find the distance of each data point from the centroid. So whenever